Hello again. We are going to begin a new discussion on a new topic. We're going to be talking about exponents and exponential functions in this chapter. So let's start off with how exponents are dealt with when we are multiplying terms together. All right, before we do that, we need to talk about some specific exponents like an exponent of 0 and any exponent that is a negative number and what those actually mean. So let's start off with what we know. I'm going to make a table in base 5. So basically in the left-hand column I'm going to have some numbers, and then in the right-hand column I'm going to be using those numbers as an exponent of 5. So if I start off with 3, then I know that 5 to the third is 5 times 5 times 5, which is 125. If I say that n is equal to 2, then 5 to the 2 is going to be 5 times 5, which is 25. And if I drop down one more, n is 1, then 5 to the 1 is going to be equal to 5. So do we see a pattern? I intentionally created a pattern so that I could continue that pattern going. If you look in the first column, the n's are going down by 1 with each row. And in the second column, if you go from 125 to 25 to 5, then I'm dividing by 5. So since that's the pattern, I'm going to continue the pattern, so that the next value of n will be 0, and 5 to the 0 will be whatever 5 is divided by 5, because I keep dividing by 5. And 5 divided by 5 is going to be 1. So 5 to the 0 is actually equal to 1. And in fact, that's a rule you need to remember. Any number raised to the 0 is 1 unless you have 0 to the 0. That's actually indeterminate. We'll get into that in a later lesson or a later course, actually. So now I drop the value of n one more, and I get to negative 1. And so that is 5 to the negative 1. And if I continue the pattern in the second column, 1 divided by 5 is 1/5. If I keep going, negative 2 is the next number if I drop by 1. And then 5 to the negative 2 is going to be 1/5 divided by 5, which is 1/25. Okay, drop one more and I get to negative 3 in the first column. So 5 to the negative 3 would have to be 1/25 divided by 5, which is 1/125th. Okay, so if you notice, I want you to see a pattern in that right-hand column because 5 to the negative 1 is related to 5 to the positive 1, and 5 to the negative 2 is related to 5 to the positive 2, and 5 to the negative 3 is related to 5 to the positive 3. Well, how are they related? We can actually rewrite each one of those by using positive exponents in the denominator. So in other words, I can write 1/5 as 1 over 5 to the 1. I can write 1/25 as 1 over 5 to the 2, and I can write 1 over 125 as 1 over 5 to the third. So negative exponents can be moved to the denominator of a fraction, and that will make the exponent positive. All right, so let's just kind of summarize what we learned in that table. If the base is not 0, then any base to the 0 will equal 1. Okay, and if I have any exponent e, if a base is being raised to a negative exponent, I can take that base and exponent and put it at the bottom of a fraction, and that will make the exponent positive. So those are nice rules to remember. So in other words, if I have 2 to the negative 5, that's actually 1 over 2 to the positive 5, which is 1 over 2 times 2 times 2 times 2 times 2, which is 32. So 1 over 32 is the same thing as 2 to the negative 5. Okay, let's talk about multiplying bases with exponents. Now I can only multiply things together and simplify them if they have the same base. So for example, if I have x to the third times x to the fourth, that's x times x times x times x times x times x times x. So that's all multiplication. So I can just see how many x's there are all together, and if I look at it, there's 7 of them. All right. If I did k to the 6 times k to the third, well, k to the 6 is k times k times k times k times k times k, and k to the third is k times k times k. So altogether, I've got 9 k's being multiplied there. So k to the 6 times k to the third is k to the 9. So what that means is when we're multiplying powers that have the same base, we can add the exponents together. So I don't need to write it all out like that anymore. Here are some more examples. If I have w to the 5 times w to the 7, that's going to be w to the 5 plus 7, which is w to the 12. Okay, it works with negative exponents as well. So if I have p to the 7 times p to the negative 3, that's going to be p to the 7 plus negative 3, which is 4. And it also works with terms with many variables. Just remember that you can't combine those variables together. You can only look at the exponents of the same base. So looking at a squared times b to the negative 5 times a to the negative 8 times b to the negative 2. If I add the exponents that are with the a's, that's 2 plus negative 8. That gives me a to the negative 6. And if I add the exponents that are with the b's, b to the negative 5 times b to the negative 2 is going to give me b to the negative 5 plus negative 2, which is negative 7. So my answer is a to the negative 6, b to the negative 7, adding the exponents because I'm multiplying terms. Okay. If there are big numbers in front, like coefficients, I still have to multiply those. So if I have 2 x to the 6, y to the 6, z to the 6 times 7, x to the 3, y to the 2, z to the negative 1, I still have to multiply the 2 and the 7 to get 14, and the rest of it, I just add the exponents of the bases that are the same. So the x to the 6 times x to the third, that's going to give me x to the 6 plus 3, which is x to the 9. Y to the 6 times y squared is going to be y to the 6 plus 2, which is y to the 8. And z to the 6 times z to the negative 1 is going to be z to the 6 plus negative 1, which is z to the 5. So just remember, yes, you add the exponents, but if you have coefficients, you still have to multiply them because this is still multiplication. All right, let's talk about exponents of exponents. If I have x to the 3 to the 5th, what that means is x to the 3 is being multiplied by itself 5 times. So that is x times x times x times x times x times x, 5 times, 5 of those. So it's x cubed times x cubed times x cubed times x cubed times x cubed. So imagine all of those x's being expanded out. How many x's would you have multiplied together? Well, you would have 15 of them. All right. So let's try k to the 7 to the 4. Well, I'd have k multiplied by itself 7 times, and that would be multiplied by itself 4 times. So that's k to the 7 times k to the 7 times k to the 7 times k to the 7. And imagine all of those k's being written out, being multiplied together. How many k's would that be? That would be 28. So k to the 7 to the 4 is k to the 28. So what that means is when I raise powers with the same base to a new exponent, then I have to multiply the exponents. All right, so here's some more examples. If I have d to the 5th to the 7, then I'm going to multiply the 5 and the 7, and my answer will be d to the 35. It also works with negative exponents. So if I have v to the 9 raised to the negative 3, then I'm going to multiply the 9 and the negative 3 to get my new exponent, so my answer will be v to the negative 27. It works with terms with many variables, but just remember to work only one variable at a time. So f to the 3 times g to the negative 4, all raised to the negative 8. I'm going to multiply each of those exponents separately by that negative 8 that's outside. So the 3 times negative 8 is going to be negative 24. So I have f to the negative 24. By the g, I have an exponent of negative 4, and if I multiply that exponent by negative 8, I get positive 32, so g will be raised to the positive 32. Okay? But you still have to raise coefficients to exponents. So for example, if I have 2 times x to the 5th times y times z to the negative 3 all to the 5th, that big 2 at the beginning, that is not going to be multiplied by 5. It's going to be handled the same way I did before I even looked at letters in algebra. So 2 to the 5th is 2 times 2 times 2 times 2 times 2, that's 32. X to the 5th is going to be x to the 5 times 5, which is 25. Y to the 5th is going to be y to the 5th. And z to the negative 3 to the 5th is going to be z to the negative 3 times 5, which is z to the negative 15. So that is how we multiply when we have variables being raised to exponents, mixed with other things, mixed with coefficients sometimes. So if you have any questions about this, please let me know, and I will see you tomorrow.